So we have discussed so far, I think, logic gates. Okay, I think today section B also is there. I think so. So today we'll discuss some one topic, very important topic. Before going to that important topic, first we'll go for a brief briefing about this alternate logic gate expression representation. Alternate logic gate representation. Usually, right? So AND gate symbols we know for AND gate, OR gate, NAND gate. Okay, suppose NOR gate and so on. Okay, so for those gates, so how we can represent alternate? In alternate way means in another way, how you are going to represent. Suppose AND gate is there. Okay, so this is usually standard symbol for the AND gate. Okay, inputs A and B are the inputs. So A dot B is the output. A dot B is the output AND function. Okay, so that can be equivalence to this type of right side. You are seeing one symbol is there. You can represent AND function is like this also. So how we will get represent here means, so A B are the inputs. Okay, here also A B are the inputs, A dot B is the output. So how it will be equivalence? Suppose here A is coming as an input, B also coming as input. I can write this as A complement or A bar plus B bar. Again here bubble is there. Bubble nothing but inverter whole bar. Okay, invert here bubble is there nothing but that is like inverter I can say. Bubble nothing but inverter. Okay, so A input is there. For the A input nothing but bubble A bar that is a bubble nothing but bubble inverter plus B bar that is bubble inverter whole bar complement. Here also bubble nothing but inverter. Nothing but if you apply De Morgan's theorem, so what is here you have A double bar dot B double bar. Nothing but A bar dot A dot B itself. A dot B itself. So that is your AND function. Okay, AND gate function. So you can represent AND gate either by this diagram or by using this diagram. Okay, clear? Just symbol is changes, but function remains same by considering the input same factor. Suppose OR gate is there, same here also same thing. OR gate function, what is OR gate function? Actually, we have A plus B you are writing. Clear? So instead of drawing this diagram, this symbol, we can draw like this also for a OR gate function. Here also same thing here. Here bubble is nothing but inverter. So A bar. Okay. Here AND gate is there. Dot. Again for B also bubble is there. B bar. Again at the output of that gate also bubble is there. Whole bar. That note here also can apply De Morgan's theorem. If you apply De Morgan's theorem, what will you have? A double bar plus B double bar. That's what you have? A bar plus B, sorry, A plus B bar, A plus B itself. A plus B itself, that is for the OR gate. That is for the OR gate function. Okay. So likewise for a NAND gate function. So for a NAND gate, usually this is the standard symbol. Okay. A, B are the inputs, A dot B bar is the output. Now that NAND gate can be redrawn or another alternate representation is like this. Okay. So here for A comma B for inputs bubble is there nothing but A bar plus B bar. A bar plus B bar nothing but it is one of the statement of De Morgan's theorem. A bar plus B bar nothing but A dot B bar itself. A dot B whole bar means for A dot B whole bar if you expand you will get A bar plus B bar itself. Okay. Next for the NOR gate. So this is the logic symbol, standard symbol for NOR gate. A, B are the inputs. A plus B bar whole bar is the output, or A plus B whole complement is the output. Okay. Now for this NOR gate, you can also draw like this. This is another way of representation of NOR gate symbol. Okay. So for A, B inputs, you have bubble is there. Nothing but complement bar. A bar dot B bar. a bar dot b bar. Okay, nothing but if you expand, if you go for the De Morgan's theorem, it will be like what is the for a De Morgan's theorem? One statement is there: a plus b whole bar equal to a bar dot b bar itself. Nothing but a bar dot b bar equal to a plus b whole bar. Okay, if you go for that De Morgan's theorem, De Morgan's theorem. So this is the another gate. So last gate, NOT gate. So you can represent NOT gate by like this, or inverter. A is the input, A bar is the output, or you can also represent like this, bubble. Okay, for the input A, if you place bubble at the word, it is A bar itself, right? You can represent a NOT gate by like this or by like this. Just here, representation of symbol, logic symbol changes, logic gate symbol changes, but function remains same. Function remains same. So this is the one small topic regarding alternate logic gate representation. Alternate logic gate representation. But our topic is, this is our topic, today topic. So canonical and standard forms. Canonical and standard forms. So very, very important topic, canonical and standard forms. So what is the statement here? Any Boolean function can be represented in either canonical or standard form. Okay, so Boolean function, any Boolean function that can be easily expressed in terms of either canonical form or standard form. So what is canonical form or what is standard form? We will discuss. So canonical form is nothing but, so just remember here, canonical form, the major terms in the canonical forms are the min terms. We have to call as a min terms. So this is a very important term in canonical form. Either you can represent by min terms or you can represent by max terms. Either by using min terms you can represent, or either you can use max terms to represent. Okay, so that is a, if it is a min terms or max terms is a number, that is a canonical form. Okay, so if it is a min terms nothing but, so taking those min terms, you have to do product, or sorry, min terms nothing but, remember here product terms. Remember, min terms nothing but product terms. Remember one point here, and max terms here, that is nothing but sum terms. Sum terms nothing but plus will be there in terms of terms here. Suppose xy, you have like this is there, x plus y plus z, and like this is there. This is a sum term here of three variables. Suppose x dot y dot z is there. So this is the product term, nothing but this is the min term I can say. Okay, right? If it is a product term, that is you are calling as a min term. If it is a, like you have a plus is there, that is a sum terms we have called, that is a max term. Okay, so how to represent a canonical form is, that is using min terms. You have to do ORing. ORing nothing but a Boolean function. It may contain a single what I can say, single min term, or more than more than one min terms. Okay, is it clear? More, that is one term or more than one terms, any Boolean function may have. Okay, if it is a more than one what you can say, min term or product term, then how to do means you have to do ORing. ORing nothing but summing you have to do. Okay, I will discuss what is ORing, what is summing, what is ANDing, next one. Okay, next topic. Just remember here, min terms nothing but product terms. Okay, so you have to collect all product terms. After collecting all product terms, you have to do ORing. ORing nothing but plus you have to do. Okay, here next, if it is a max terms form, nothing but sum terms. If it is sum terms are there, then you have to do ANDing. ANDing nothing but product. Okay, in here you are doing sum here. Here you will do product here. That is the only difference. For a canonical form, it may be some that is min terms or max terms. Okay, so this is one form you can any Boolean function can represent canonical form, either maybe min term form or maximum form based upon that given expression. Okay, or next another is there standard form. So we can represent any Boolean function by a standard form also. Standard forms are two types here also. So one is sum of products form. Sum of product, nothing but short form given SOP. SOP in the sense sum of products form. Okay, POS, product of sums form. product of sums form. These are the two forms. If the expression is in these two forms, that is a standard form. That is a standard form. Suppose if the Boolean expression is in like min terms are there, max terms are there, so that is we are calling as a canonical form. Okay, so if you discuss that is the difference between these two things, canonical form or standard form. If you go into through this topic, we'll get the difference. So how we can differentiate between the standard form and a canonical form, we will discuss now. Okay, so just get this idea regarding which I have drawn here for a canonical form and standard form. Just go through this thing. That's it. So if we go for deeper, we can easily understood. Okay. Now, first of all, we'll move to the canonical form. Right. So canonical form is, see here. I said already min terms and max terms. Okay. That's why I have drawn one table here. Min terms and max terms, a representation of three binary variables. I have considered three binary variables are x, y, z. X, y, z are the three binary variables. So for those three binary variables, so I have listed the min terms and max terms. Min terms and max terms. Okay. So like this, we can list here. See x, y, z. X, Y, Z three binary variables. So nothing but here it may be zeros and binary in the sense x may be 0 or 1, y may be 0 or 1, z may be 0 or 1. Okay. So three binary variables. Nothing but how many combinations here? How many input combinations? You have 2 power 3. Three variables, 2 power 3. Nothing but how many combinations? 8 combinations. Okay. 8 combinations in the truth table. So eight combinations in a table, suppose. So this is one. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Total 8, starting from 0 to 7. So because this is three variable. Okay. So this is how we can go for the input, that is binary variables x, y, z. It may be 0, 0, 0, first combination 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. Okay. 1, 0, 1, double 1, 0, triple 1. Clear? So suppose in the min terms forms, how we are going to write? So if it is a min term form, so write as it is. If it is a 0, okay. So sorry, if it is a 1, just represent like non-complemented form, uncomplemented form. Okay. Is it clear? Suppose if it is a 0, so write its complemented form. Complemented form. Clear? So x is 0 here. Nothing but what will be the form here? X bar. Y is 0, y bar, z bar. Nothing but this is product term actually. Okay, I haven't mentioned dot here. Right? So x bar dot y bar dot z bar. Nothing but this is one min term here. So that is how we are going to designate m0, small m0, small m0. Clear? Next, go for next one. X bar, y bar, z as it is. Next, 0, 1, 0. X bar 0, y is 1 here, that's why I only have written y. Next, z is 0 here, that's why z bar. That is 2, m2. Suppose m3, x is 0, x bar. Y, yz 1, 1, that's why 1, 1. That is m3. Next, x is 1 here, that's why only x non-complemented form. Yz are zeros, that's why y bar z bar. Okay, that is m4, min term 4 or 4 you can go for, no problem. Next 101, nothing but 5 actually. So x is 1 and z is 1. So x z. So y is that complemented form. That's why y bar. Next x equal to 1, y equal to 1. X y as it is. Z is non-complement. Sorry, complemented form. That is z bar. Next x y z non-complemented form. That's why x y z 7. Okay. So you can designate min terms like this: m0, 1, 2, 3, 4, 5, 6, 7. So this is for only three variables. Suppose Boolean function may be like 2 variable, 3 variable, 5 variable, n number of variable. Clear? Is it clear? So just I have listed uh, only for the three variable, min terms and max terms. Clear? So this is about the min terms representation. Then how to represent the max terms? Now, how to represent a max term is here. See here, I said already previously. So min term nothing but product terms. Max term nothing but sum term here. Clear? Now, how to get the maximum from the minterm is just you apply De Morgan's or apply complement to these minterms. Apply complement, whole complement to all these minterms. For each and every minterm, apply whole complement, then you will get maximum. Then you will get maximum. Clear? Suppose if how I can get the maximum for this 0, nothing but 0 means actually minterm form x bar, y bar, z bar. In maximum form, that is a x plus y plus z. X plus y plus z. How it comes means just by applying here complement here for a minterm. Apply whole complement for a minterm. Then what will have you what will be you having? That is here you have x bar, y bar, z bar. Okay, whole bar or complement. Then how will get here x double bar plus y double bar plus z double bar, nothing but x plus y plus z. So that is here I have written here. So that can be designated as m0. That can be designated as m0. Okay, right? So next m1, same as it is. So apply here complement here. Apply complement, then you will get max term. Okay, apply complement to minterm, you will get max term. Apply complement to minterm, you will get max term. Okay, clear? So like this, you can go for here. Any doubts here for this table?
No, sir.
Right. Or if you have the max term, you can from the max term you can get minterm. I think here also if you apply x plus y plus z whole bar. Okay, what will get here? X bar dot y bar dot x bar dot y bar dot z bar. Right. If you apply complement for the maximum also, you can get the minterm. So bidirectional, it is a bidirectional, not unidirectional, it is a bidirectional. Okay, means here if you get minterm you can get maximum. Or if you, that is suppose in the function given minterm you can get the maximum. Suppose in the function given only maximum you can get the minterm. You can get the minterm. Okay, so remember, so that is very important here. So this is one table for minterms, that is a small m representation, that is 0 1 2 3 4 5 as it is. For maximum capital letters, capital M, capital, that is m1 m2 and so on. Next we have one table for this regarding another uh, representation. Okay, I will write that one. Wait. Okay. Suppose, for example, so x, y, z. X, y, z. So three variables. Suppose 8 combinations 0 0 1 0 1 0. Okay. 3 4 5 6 7. Suppose f equal to given like this 0 1 0 0 1 double 0 1. Okay. So given like this. This is a function on example. Just for a that is three variables x, y, z are inputs. F is the function of those three variables, and f is the output. F is the output. Then how to represent using this truth table? Suppose this is a truth table. So using this truth table, how you can represent in sum of minterms and sum of maxterms form? Okay, clear? So for this one, first to take minterms. Minterms means so which is having one, which produces function one. So which produces functions one are this is 1, 2, and 3. So three terms are there which produce the function one. Nothing but those are the minterms. Okay, those are the minterms. Then how we can write here? F equal to so x bar y bar z, x bar y bar z plus another x y bar or y complement z complement plus x y z. Okay, so this is minterms here x bar y bar z, x y bar z bar, and x y z. So what I am doing here, I am representing that function in sum of minterms form, I can say. Okay, so these are the minterms. So what I am doing here, ORing nothing but sum. Previously I have
థర్డ్
explained
టర్మ్ లో జెడ్ బార్ కదా సార్,
yes, ma?
థర్డ్ టర్మ్ లో సార్ జెడ్ బార్.
X equal to 1, y equal to 1, z equal to 1. That's why x y z.
Sir.
ఓకే సార్.
Okay, madam.
Is it clear?
ఎస్ సార్.
Yes, sir.
Okay, fine.
Yes, sir.
So I have given in that starting itself. So sum of that is minterms form, that is what product terms you have to take, and finally you have to do ORing. ORing nothing but sum you have to do. That's why I have done here sum here. Plus this indicates sum here. Okay, so this is what I can say sum of minterms form means one of the canonical form, or I can write like this also, f equal to so this is 0, 1, 2, 3, 4, 5, 6, 7. Nothing but I can write here m1 plus this one m4 plus xyz m7 m7, or you can write like this also, or f equal to 1, 4, 7. In some test book they will give like this summation of small m or capital M, or directly they will give like this summation. Okay, why summation means you are doing plus here. What are the minterms? 1, 4, 7. Clear? You can do like this. So these are the minterms. Then what are the maxterms? The remaining functions, the remaining terms, which, those are the maxterms. Okay, what are the remaining terms here? We have 0, 2, 3.
Not M2, M.
Right. So 0, 2, 3. Here we have 5, 6. Okay, how many are there? 5 are there. Remaining 5 terms, that is 0, 2, 3, 5, 6. These are the max terms. These are the max terms. Means here that function may have like only min terms or only max terms. We don't know. Okay, it may have only min terms or it may have only max terms, or some terms will be min terms or some terms will be max terms. Okay, so this is one form here. That is, you are writing here, you are expressing that Boolean function in sum of minterms. Okay, clear? Suppose, so how to represent like maxterms form? Okay, so maxterms means just now I said how to get the maxterm is Next page. Wait, I'll go for the next page. So same thing. This is f I am writing. Now I will write f bar. Why f bar? For minterms, just you can write f equal to summation of 147 like that. In order to get max terms, first step is we have to write f bar. Why f bar means we are moving from 1 to 0, complementing. You need to complement, means ones are over. Next you have to go for zeros. In order to go for the in order to write the max terms, first you have to write convert function into its complement form. Then you can write max terms. Sorry, then you can write max terms here. So f bar equal to what are the maximum? 0. Okay, so 0 means what is 0? Here you have x is 0, y is 0, z is 0, nothing but x bar, y bar, z bar plus next 2. 2 means here 2 means x bar, y, z bar plus 3 also x bar, yz, right, plus 5 x, y bar, z. Next is 6 plus x, y, z bar. What I have written here, I have written just function with respect to its max terms. Okay, max terms I have written. Clear? I haven't get that max term form. Just I have represented max terms with respect to that function. By complementing function, I can get for that max term f bar. Now, how to get the max term form means? So you have to do apply complement on each side, what will get here? F complement, whole complement, nothing but x bar, y bar, z bar plus x bar, y, z bar plus x bar, y, z plus x, y bar, z plus x, y, z bar whole complement. Okay, f complement whole complement, what f double bar, nothing but what is f double bar?
F.
F itself. Okay, now here you have that form here. What is this form here? De Morgan's theorem, x plus y whole bar, nothing but x bar dot y bar. Here you have 1, 2, 3, 4, 5 terms are there. Those 5 terms whole complement. Okay, then you have to write this form, x bar dot y bar dot form, x bar dot y bar dot form you have to write. Nothing but if I write that one, what will happen here? X complement, y complement, z complement. Okay, whole complement
Whole complement.
dot next this one, x complement, y, z complement whole complement dot x complement, y, z whole complement dot x, y complement, z whole complement dot x, y, z bar whole complement. Then how can I write here? F equal to, again De Morgan's theorem, x dot y whole bar, x bar plus y bar. Okay, x double bar, directly I am writing x
X plus y plus z.
X plus y plus z, sir.
right, directly I am writing here x plus y bar plus z dot x
Y bar.
plus y
Y
bar
bar plus
z
Z.
bar
Z bar.
plus dot x bar plus y plus
Y plus
dot
Z bar.
dot x bar plus y bar plus
Y bar plus Z.
z. Nothing but f equal to what is x plus y plus z? Capital M0 dot. This is 2, I think. X bar y bar, right? 2 3,
2, sir.
right? M2 dot M3 dot
M5.
M6
M5.
M6, right? You can write like this also. Product of max terms. Max terms. What are the max terms? 0, 2, comma 3, 2, comma 3, comma 5, comma 6. Product. Okay. Sum of max terms. Sorry, sum of min terms, first one. So product of max terms. Okay. So this is the thing you have to do like this. Directly function will be given like that using that min terms, max terms. Okay. So we have to simplify those min terms, max term function. So this is the one canonical form. Either you can represent like sum of min terms form or product of max terms form. So that is a canonical form. Canonical form. Next, standard form. Standard form also simple thing. How we'll get the standard form is just like after like some simplification. Okay, after simplification of sum of min terms form or sum of product of max terms forms, you can get standard form. Means after simplifying the canonical form, a function can be goes to like or represent in as a standard form. Clear? So I will add that point here. If any simplification in canonical form, if any simplification in canonical form, then we can go for standard form. Okay, so simplification in the sense, suppose like already we have discussed about like Boolean laws, Boolean theorems. Okay, if you have any simplification, that is if you want to go to standard form from canonical form, means you can apply some Boolean laws, theorems and so on, De Morgan's theorems and all the theorems, then you can go for the standard form. Means here in the standard form, okay, function cannot be like terms will not be like min terms or max terms. Means min terms, max terms will not be there in a standard form. Okay, standard form means it may be sum of products, SOP or POS. SOP, POS. In SOP and POS, okay, like we don't have min terms and max terms. Okay, SOP or POS is a simplified form of that sum of min terms and sum of max terms form. So, sorry, sum of min terms and product of max terms form. Product of max terms form. So that is very important point here. Okay, so just for the example, I will write one example here. F equal to or f1 equal to y bar plus xy plus x bar y bar z bar. Suppose f2 equal to x dot y bar plus z x bar plus y plus z bar. Suppose by seeing this f1 and f2 functions, f1 and f2 function. So by seeing those functions, we can say, so those two functions are in standard form. How we can say standard form is just now I said here. Suppose f1 equal to, we have how many maximum variables, how many are there here? X, Y, Z, three variables. Okay. So these three variables should cover in other terms also. Means these three terms are there in, that is y bar, xy, x bar, y bar, z bar. In three terms, in the first and second term, okay, all variables are not covered. All variables are not covered means if all variables are covered, that is a canonical form. If all variables are not covered in terms, okay, so that is a standard form. Suppose here y bar is there, first term. Here what are the variables missing here? X, Z are missing. Okay, x and z missing in first term. In second term, z missing. Okay, nothing but here missing or nothing but this is a standard form. Clear? Suppose in function f2 here, so this function f1 nothing but a SOP form. We can write sum of products form. Sum of products. F1 is nothing but one example for the SOP form. Okay, sum of products. Product terms will be there. What are the product terms here? Xy, x dot y, nothing but xy. Another is there x bar dot y bar dot z. That is a product terms. Right? So product terms are there. You need to do sum. Plus is there. But it is a SOP form. Okay. Suppose here f2 function is there. So these terms are the product terms. These terms are the product terms. X, y bar plus these terms are these in this one sum terms. These are y bar plus z, one sum term. Another sum term is x bar plus y plus z bar. Two sum terms. Clear? Suppose for the first here first term only x is there. What are the missing here? You have y and
Y and Z, sir.
right, y and z missing here.
Why is it?
In second one, x is missing here. X
Yes,
is
sir.
missing. Nothing but this is purely standard form.
Yes, sir.
Purely standard form. If variables are not missing, that is a canonical form. If variables are missing, that is a, I can say that is a standard form. And but this is purely, we can say these are like the product of sums forming. This is actually POS. Product of sums. Sum terms will be there. At last you have to do product. You have to do product. That's why we call as a product of sums. Okay. Sum of products means product terms will be there. You have to do sum. Okay. POS means sum terms will be there. You have to do product. That's it. Clear? So by seeing that function or that is function Boolean function, we have to identify whether the function is in sum of form, the function which is in canonical form or standard form. We have to identify whether it is a canonical or a standard form. Okay, so this is one very important point. Clear? Suppose I think to draw logic diagram, you know already how to draw the logic diagram. You can draw logic diagram, no problem. Most of the questions they will ask about the draw the logic diagram. Draw the logic diagram. So based upon the product terms, based upon the sum terms. Okay. Suppose based on the product terms, we require AND gates. Based upon the sum terms, we require OR gates. Clear? Right? So that is also very important. Like a logic diagram, logic circuit diagram or logic diagram for a given Boolean function. Clear? Right? So this is the thing here, standard forms and canonical form. So one point here. Okay. One problem I will do here. Convert the following to other forms. F of x comma y comma z equal to summation of 1 comma 3 comma 5. Second one, f of x comma y comma z equal to 0, 3, 6, 1. Sorry, 0, 1, 3, 6. I will write product here. F of x comma y comma z equal to product pi 0, 1, 3, 6. So convert the following to other forms. So usually the given function, so those are in canonical form because minterms given for the first one minterms is there, for the second one maxterms is there, right? So this is the thing here. So what are the maxterms for this? 0, 2, 4, 6, 7. Next for this one, what are the minterms here? 3, 4, 5, 7.
7.
Okay, clear. So what you have to do, you have to take this one 0, 2, 4, 6, 7. Okay, just now how we did here, I have given an example here in that truth table, zeros and ones nothing but minterms, zeros nothing but max terms. So already you have minterms are there. You can easily get the max terms just by complementing that function. You will get the max terms. Okay, so represent. You can do like this. You can convert by doing like this. Conversions will be there and also expressing. Just convert means you are going to convert from that is minterms to maxterms or maxterms to minterms. Suppose in the question like express is there, convert the following to other forms and express. Express in the sense, so we have to do each and every step. What are the steps? Just now I discussed it here. Okay, minterms, maxterms, how to get the minterms, maxterms, apply complement on each side, and you have to get like this. That step you have to do. Now we are not required now. So just uh, for example, I have discussed this one. Okay. So this is the one today topic, sum of minterms, product of maxterms. So I think you got some idea regarding this thing.
Yes, sir.
And other one point is there. Suppose here function will be given like suppose here this function will be given y bar plus x dot y plus x complement y complement z complement. So convert this function or this SOP into canonical form. Like that also can get questions. Clear? Are you getting my point here? So standard form to canonical form or canonical form to standard form, that may be possible. Means I said already here, suppose for this example f1, in the first term x comma z are missing here, right? So we have to include this x comma z in order to convert this standard form into canonical form. Including means how you need to include means by using applying some theorems. Applying some theorems. What are the theorems? We have like Boolean theorems, Boolean laws. Using those Boolean laws theorems, we have to apply what are the missing terms, missing variables are there. We have to include in that one. Suppose next year, second term, z is missing here. Okay, you have to include z in this one. How means by using that Boolean law. Suppose you have z is missing here. If you do like this, z plus z bar for the second term. What is z plus z bar? 1. Okay. If I write here z plus z bar, that makes no difference. Z plus z bar is equal to how much? 1 itself. Suppose here in the first first term here, x and z are missing. I can write x plus x bar and z plus z bar. Even though if I write, it will be y bar itself. Okay. X plus x bar, z plus z bar. You need to again you have to do what I can say like multiplication. Okay, so like that you can obtain the given standard form into, you can convert the given standard form into canonical form. Canonical form is either sum of min terms or product of max terms form. Product of maximum form. So remember here, so but it is a bidirectional. You can convert either canonical form to standard form or standard form to canonical form. The only thing is the Boolean laws theorems you have to get. Boolean laws theorems should practice. Okay. Right, x plus x bar equal to that theorem, that one, and we have distributive laws there. Okay. Associative law, distributive law. So we have so many things like De Morgan's theorem. Clear? So by using those rules, we can easily go through that one. We can easily convert. So this is about the today topic, sum of min terms, that is standard form and canonical form. Any doubts today class?
No, sir.
Okay.
Mid syllabus.
Bit syllabus. So tomorrow I will take morning. I will take on class.
Okay, sir.
Tomorrow morning one class is there. Up to tomorrow morning class syllabus. Okay. Right. Thank you, ma.
Sir.
Attendance, sir.